with any address DV. So if the same address is accessed by the different master, but on a different ID, so it will not overwrite the entry. It will just create a new entry and keep the exclusive monitoring for both the masters. Okay. So whenever a exclusive read will be generated by M1, so it will complete its exclusive monitoring on first entry. Whenever it will generated by M2, it will complete with its own entry. Huh. Now let's say this is the scenario. This is exclusive read by M1, M2, and the data is also present as AA. Now my M2 is performing a write operation on 8 ID 0 cross 04. M2 is generating a exclusive write with data CC. Okay. And after 7, so it will get the OK response or XOK response.
X okay.
XOK is respond.
XOK. Now I am generating the M1 is generating the ID 7 0 cross 04. M1 is generating the transaction of its exclusive write with data DD. What should be the response for this?
Still XOK.
Why XOK?
Because the entry of the M1 is still there.
Hmm. But if you see the address location is same, but now the data has been overridden. It is not the previous data.
But you said it what the new entry.
Yes, but it is also like the entry is different, but the memory locations are the same. For this entry, it is not storing the data on a different, like its own, like data is not stored like this. The data is picking up from the memory only. Okay, so I can like this is the address location. The data was AA, so that is the common. Now the data is overridden to CC. So whenever the data exclusive write is happening, it will check on the 04 address. The data has been changed, so it will result in a
Fail.
OK response.
Okay.
Yeah.
Okay, respond.
So the monitorings are happening on the attributes like ID, address, size, burst, and all those. नहीं वो नॉर्मल राइट है वो तो अपना नॉर्मल ओके या एरर जो भी है so you just like it's all about the exclusive I think so you just read the spec because there are some like all these conditions are mentioned. It's not a big 2 or 3 pages are there only 2 pages. So all the conditions are there like what should be the burst type, what can be the maximum length, what kind of attributes are there, the IDs should be same. So all these conditions are mentioned. You just go through the like the specification and then we can like discuss some of the questions. Like all the questions are like this only. Like if M1 is generating exclusive like read and in between some write is happening with the same ID, same address. So what will happen? It's a OK response or X OK response. The question will be like this only. आज ही है Okay, so just go through the protocol for this exclusive write, exclusive access. That's all in this exclusive monitoring, and the transactions are like this only.
सर ये तो इनिशियल में था एक्सक्लूसिव रीड से शुरू होगा तो सब कुछ
Uh, and in logged access is nothing like in AXI3 we have if we are generating a transaction with a logged. So that now let's say we have this M1, M2, knock, S1 and S2. M1 has generated a lock transaction on S2, so it is just blocking the path from M1 to S2 until a unlocking sequence has been generated. So whatever the transaction we are sending in between the lock and the unlock sequence, the knock will give priority from M1 to S2 only. If M2 is trying to access to S2, knock has to hold the transactions going towards the S2. So this because it is adding the complexity, so much of complexity in the knock, so that's why we have removed it in the AXI4. So we have removed this in AXI4. You can just read out logged access is nothing like you can just read from the protocol itself. Okay, one more thing in exclusive write and read any about the application where we can use the exclusive write and read operation. Everyone has heard about the read modified write. Read modify write transactions. So what we do in read modify write is like we are reading a transaction from an address, modifying the data and writing it back to the same location. So in that case, we are using this exclusive access because we don't want to change the attributes and the previous data should be maintained. We are performing some of the operation on the data. What kind of like let's say we have a 32-bit register. Okay, and I only want to update one bit of data in that register. So how we can do it? Like just performing a read to this 32-bit register, update that one bit value and perform a exclusive write to it. Okay, so that now let's say the FFCC. This was the read value, and I just want to change one value and generate FFBC. Okay, any update. So what the thing is, the previous data should be maintained. In case any other transaction has updated the data with like let's say AABB. So whenever I'm writing the FFBC, it is the incorrect one because now the register has been updated with AABB. That's why if a write operation is happening in between the exclusive read, we are giving a OK response. That's why the exclusive transaction is getting failed. You got with the application why, like how it is happening. What is the basic use of this exclusive with this example? Read modify write. Hello, hello. Any issue with this example? Like, yeah.
Can you teach some about it, sir?
Okay, I'll re-explain this read modified write. Now let's say we have a 32-bit register, okay, and it it can be any like debug register in your IP or in your verification environment anywhere else, okay. So and I just want to update one bit of data. So with the normal access so far, what transaction we have read, like our fixed bus is there, INCR, wrap bus, can we update one bit of data using those transactions? To a 32-bit register, can we update 1 bit of data? Answer is no, like no one is saying something. Okay, so at least 1 byte of data should be updated, the minimum. So if we want to change some bits, or let's say in a 32-bit register from 12 down to 8, 12 down to 8, my bits are reserved, or let's say it is read only, and I don't want to write to those bits. So what we can do, we can just read out the register. Like whenever I'm performing an exclusive read, I can just read the register and update only the read write bits, and update the register with the exclusive write. So I've taken, let's say this is the exclusive read, this is a normal write, and exclusive write. So first I'm doing this. Now I'm performing exclusive read with the value FFCC. I'm updating only 1 bit of data, FFBC. Okay, there are 2 bits actually. EC. So when I'm updating it, I'm getting okay, the previous data is maintained, all the attributes are same, so I can update the data. But now let's say a normal operation is there, a normal write to same address, same register with a different value of AABB. Now this exclusive write, my changing of this bit has no value because the value of register is being updated by some other master or some other normal write transaction. So that's why whenever I'm performing this exclusive write with FFEC, my response will be okay. What we discussed over here now, like I'm performing exclusive write. So same way this exclusive read is happening by M1 and M2 as well. Okay. My exclusive write is generated by M1 with FEC. It is giving me the XOK response. But now whenever my M2 is generating a exclusive write with let's say F FFCE, it will be a OK response because it is generating FFCC based upon this. But now the value has been updated to FFEC of that register. So that's why it is causing us the failure.
And right now, what the data in there, sir?
What would be the?
So this guy, the last data in the memory, what?
No, this data will be discarded. It will not update it. It will not update the memory. This M2 transaction. M2 again has to again has to perform the exclusive read. Then it will get the read data as FFEC, and then it can perform the exclusive write with some updated data, FFEE. Then it can generate our XOK response. So the data should not be changed, all the attributes should not be changed, basically.
Sir, so in exclusive access, always the data change that we do, or like in read, modify, write, it can be only
Hmm.
for 1 bit data.
No. It can be any bit, like based upon the registers. Like I said, let's say a 12 down to 8 is a reserved bit. My let's say sixth bit is read only. So I don't want to write to those bit, but all the other bit I would just perform at the read write bit, and I just want to change their values. So we can perform any like irregular bits if we are just performing the write. So that can also be possible. or there are sometimes, let's say we are like CPU is reading out some kind of instructions, let's say, and it has to perform some kind of operation like arithmetic operation or logical operation it has to perform and update to the memory back. So that can also be the one possibility, one kind of example on this.
Okay, sir. ठीक है. Because of this condition, it should be only 1 bit data change. Otherwise, it can be more bits.
Yeah, I have taken just an example like
ठीक.
for this one bit.
So we have to send the exclusive read first.
Read, yes. Every time exclusive read should be the first. In case we have generated a exclusive write as a first transaction, because there is no monitoring happening on that particular address, let's say there is no exclusive read, we have directly sent the exclusive write to the 8 and 04. So no monitoring is happening to that address and ID. So we get the OK response every time and the memory will not be updated.
So it cannot send exclusive try first, right, sir?
Yes. Every time exclusive read should be the first transaction.
Yes.
Yeah. So just uh, keep remember like this some example on this for read modify write and just read the protocol, the things will be more clear to you. And just remember the conditions because there are some more conditions on that. Okay. Like the value of cache, maximum burst length, and list I think we have covered. Okay. So now coming to protection type. यार ये नहीं समझ आएगा यार, पता नहीं, बहुत कुछ है उसमें, राइट एलोकेट रीड नो एलोकेट, मेरे को भी एक बार पढ़ने पड़ेंगे अभी वो. So basic prot will cover, okay, and what is cacheable, bufferable, non-bufferable, that thing I'll explain. So that will be, I think, sufficient in EXI, but later on you can just go through the specification. So what are the access permission? We have this AW prot and AR prot signal of 2 bit, 3 bit. So these are the values, possible values. So 0 indicates the privilege or non-privileged transaction, secure, non-secure, and data instruction. So it is like from data instruction access, I think it is quite clear. Whenever the prot value, the second bit of the prot value is 0, that means we are like we are trying to access some kind of data. Now let's consider like if I think there is a DDR. Okay, DDR is like the DDR controller takes the transaction through the AXI interface. So we can send the prot value, the second bit of prot value as 0 whenever we are accessing the data. But now if we are accessing some of the registers in the controller, then we can set the value as 1 of the second bit. That means the some kind of instructions we are sending or we are updating some kind of configuration. So this is a basic difference in data and the instruction access. Okay, so
मेरे चांसेस
सही है. Okay, this is clear. Like, what's the difference in instruction and data access? Hello.
Yes, sir.
Okay. Anyone else? Any doubt? And secure and non-secure. So, like in SOC, we have everyone has seen we have some kind of SRAMs, or in a memory we have the different kind of segments as a secure and non-secure access. So, secure will be accessed only by a secure master. Okay, a non-secure transaction cannot access to a secure region. A, sec- a non-secure cannot access to a secure access region, but a secure can access to both secure and a non-secure. So it is basically like it is quite clear with the name. Like what is a secure memory and a non-secure memory, and about the privilege and non-privilege access. So privilege is about about the resources. Okay, like in privilege access, all the resources are available. Like in a particular IP, we have multiple features, multiple resources. So in privilege access, everything is available. But in unprivileged access, some restrictions are there. All the features, all the resources are not available. Okay, so privilege is about the availability of resource. Secure, non-secure is about the memory regions, instruction and data. So whenever we are using the data access, we concerned about the secure or non-secure access. And along with the instructions, we are concerned about the privilege or unprivileged access.
secure non-secure को तो समझना आ गया
Hmm.
data regions पे dependent है privilege non-privilege का क्या है?
So in instruction, when we are giving some kind of instruction, we are accessing some kind of resource. हम कोई configuration, we are hitting to some kind of configuration. So it's not necessary like to that particular master, all the instruction sets are available. Okay, so might be for M1, some instructions are restricted, it is being masked. So that is like a unprivileged access. This master has not the availability to all the resource. But our, let's say our CPU is there, and let's say our some small another host is there. CPU has the access, it's a privileged master, it has access to all the resource of the slave, but some other unprivileged master has access to only first 10 resources, not all the resources. So that's about the privilege and the unprivileged access.
जब master एक छोटा master
वो अनप्रिविलेज एक्सेस ही कर रहा है बाय डिफॉल्ट, और जब सीपीयू कर रहा है वो बता रहा है कि मैं सीपीयू हूँ, मतलब वो प्रिविलेज एक्सेस कर रहा है, कि वो बता रहा है कि मेरे पास सब कुछ, मैं सब कुछ एक्सेस कर सकता हूँ. आई सीपीयू इज टेलिंग आई कैन एक्सेस ऑल द बिट्स, everything. So it is sending the prod 0 value to 1.
जब वो छोटा master transaction send करेगा
Hmm.
तो
So if the unprivileged master is trying to access the privileged things, so that is not applicable. That is a illegal transaction. Same as a non-secure master cannot access to a secure region.
तो even if वो master अगर उसकी unprivileged जो है privileged places जो है वो access करने की कोशिश करता है prot 1 करके privilege access करके
That will be a slave error.
it will be a slave error. ठीक है, बट अगर सीपीयू उसको privilege part को access करेगा तो वो prot 1 करके
Hmm. Okay, so this is clear, like what's the difference in all these 6 terms?
उसमें एनडी वाले वो भी होंगे ना लोग,
बाय सुन, ये प्रशांत
6
है ना?
गेस्ट हैं उसमें। ये नीचे तुम हाँ नीचे यहाँ पे होंगे ना ये लोग।
डिफरेंट है।
सर ये टीम
आपका
है
जब
सेम
शेड्यूल
मेरी
हुआ
में,
था तब 1 घंटे का हुआ
जो
था
ये भेजा ना
शेड्यूल।
हाँ
सेम ये टीम मेरी।
आपका जब शेड्यूल हुआ था तब 1 घंटे का हुआ था।
हम लोग आधा घंटे का।
Okay, so I think any doubts so far?
We
Voice is getting echo. Can you repeat?
No, sir. No.
Okay.
Now.
So I think we can wrap up for today because there's some other discussions as well. Okay, but please go through the specification. Okay, read all the topics like, because so far we have covered all the topics. Only thing left is like the cacheable, non-cacheable, bufferable, non-bufferable. Okay, and the hazards are also there. So just go through all the things, how we like how the scenarios will be there if we are implementing in a SOC. So please start reading the protocol. Okay.
yes, sir.
Yeah. And on Monday, I think we can have like some kind of doubt session as well as some questions, like random questions. Abhishek sir, I think he'll also join.
Yes, sir.
Okay, so
Okay.
thanks everyone.
Yeah, thanks.
Thanks. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye.